On October 19, 2017, an astronomer named Robert Verick was analyzing routine data at the Haleakala Observatory in Hawaii. His mission was critical, yet standard, scanning the night sky for near-Earth objects, rogue asteroids that would potentially end human civilization. Instead, his telescope captured a tiny faint speck of light drifting through the constellation Pegasus. At first glance, it looked like just another routine discovery. But when scientists ran the tracking numbers to calculate its orbit, the computer systems did something unexpected. They flagged a massive anomaly. This object wasn't looping around the sun in a neat, closed ellipse like a normal asteroid or comet. It was moving at an astronomical speed of 26.3 kilometers per second relative to the sun. Its orbital eccentricity was calculated at 120. In celestial mechanics, any value greater than 1.0 means the object is on a hyperbolic trajectory. It wasn't bound to our sun's gravity. It had come from interstellar space, the vast, empty, freezing void between the stars. It was the first interstellar visitor humanity had ever detected in recorded history. They named it Oumuamua, Hawaiian for a messenger from afar, arriving first. But as the world's most powerful observatories swiveled their mirrors to track the messenger, excitement turned to deep, scientific unease. It wasn't behaving like a rock. In fact, it was doing things that science said were physically impossible. To understand why Oumuamua terrified the scientific community, we first have to look at its physical appearance. Because it was so small and traveling so fast, no telescope on Earth or in orbit could take a direct high-resolution photograph of it. To us, it was just a single dim pixel of light, but astronomers had a clever way to see its shape. They monitored its light curve over several days. As Oumuamua tumbled through the darkness, it reflected the distant light of our sun. Every 8.1 hours, it completed one full rotation. But as it spun, its brightness varied drastically by a factor of 10 or 2.5 magnitudes. For an object's brightness to change by 10 times, it means its length must be at least 10 times greater than its width. Imagine a cosmic needle, or perhaps a flat, pancake-like disk, estimated to be roughly 400 meters long, but only 40 meters wide. In astrophysics, a 10:1 aspect ratio is unheard of. In our own solar system, there are millions of catalogued asteroids and comets. Not a single one of them has an aspect ratio greater than 3:1. Gravity naturally pulls large cosmic bodies into spherical, blocky, or irregular potato shapes. For an object to survive the harsh gravitational tides of interstellar space with a needle-thin geometry, it would have to possess immense structural integrity. What kind of natural process could create something so thin, so long, and so incredibly durable? Some astronomers suggested it was an ancient metallic shard, but the real mystery was yet to be uncovered. The shape was bizarre, but the real crisis began in June 2018, when astronomers analyzed tracking data from the Hubble Space Telescope. As Oumuamua completed its loop around the sun and began its journey back out into the cosmic dark, it did something that defied gravity. It accelerated. According to Newton's laws of motion, as an object moves away from the gravitational pull of the sun, it should slow down. But Oumuamua was speeding up. It experienced a systematic, non-gravitational acceleration of approximately 4.9 times 10⁻⁶ power meters per second squared. Now, there is a common, natural explanation for this behavior in space. When comets get close to the sun, solar heat vaporizes the ice locked inside them. This creates a spectacular tail of gas and dust, a process called outgassing. The escaping gas acts like a rocket booster, pushing the comet forward. But when scientists turned their most sensitive infrared cameras, including the Spitzer Space Telescope, toward Oumuamua, they found absolutely nothing. There was no dust, no gas, no water vapor, no carbon monoxide, and no carbon dioxide. If Oumuamua was outgassing enough to push a 400-meter object. It should have left a massive, easily detectable trail. Furthermore, the violent forces of outgassing would have dramatically altered its rotational spin rate, yet its 8.1-hour tumble remained completely stable. It was accelerating with no visible engine, no exhaust, and no fuel. The scientific community was thrown into a state of panic to salvage the idea that Oumuamua was a natural rock. Scientists began proposing increasingly elaborate, complex, and exotic theories. One theory suggested that Oumuamua was a hydrogen iceberg, a chunk of solid molecular hydrogen born in the freezing cores of giant molecular clouds at just 15 potassium or 258 degrees Celsius below zero. If solid hydrogen evaporated, it would be invisible to our telescopes, explaining the acceleration without a visible tail. But this theory quickly collapsed under mathematical scrutiny. Other astronomers calculated that solid hydrogen icebergs are incredibly fragile. Over a journey of millions of years through interstellar space, starlight and cosmic rays would have melted the iceberg long before it could ever reach our solar system. Researchers proposed it was a nitrogen iceberg, a piece chipped off an exopluto, a planet in another solar system made of solid nitrogen. But critics quickly pointed out a fatal flaw in this math. To produce enough nitrogen fragments to explain finding one so easily in our solar system, the galaxy would have to contain an impossibly massive amount of nitrogen, far more mass than is physically available in all the star systems in our galaxy combined. Every natural theory required scientists to invent an entirely new class of cosmic object, something never before seen, and highly improbable. It was at this moment that one of the most prominent voices in modern science stepped forward with an alternative explanation. One that didn't require inventing new physics but did require rewriting our understanding of our place in the universe. There were no radio signals, no transmissions, no signs of electromagnetic activity. To supporters of the natural theory, this was proof Oumuamua was just a rock. But to those who suspected an artificial origin, it only deepened the mystery. If Oumuamua was a machine, it was either completely dead, running on passive instruments we couldn't detect, or its creators had moved far beyond primitive radio waves to targeted laser communications. By the time scientists realized Oumuamua was behaving strangely, it was already too late. It was traveling millions of miles away from Earth every single day, escaping our solar system at a velocity that no human spacecraft could match. We watched it slip away into the dark, cold void, taking its secrets with it.